numbers. Not anything earth-shaking and startling new for you, but under numbers, we're going to talk about first of all, let's draw a number line. A number line, which looks somewhat like this. It's called the number line because it is a line that has numbers on it. So let's start here at 0, and then 1, and then 2, and then 3, and then 4, and then 5. And the first thing we're going to talk about is what are counting numbers? Anybody care to speculate counting numbers? Good, I'll tell you. How about this? It's only been, wait, how old are you people?
11.
About, probably 10, say 9 years ago, when you were just teeny tiny little kiddos that were learning to walk and do all that, your parents taught you how to count. If you could reenact your parents teaching you how to count, anybody, how did that work, do you suppose? Maybe if you have a little brother or sister or whatever. Sarah Grace knows.
1, 2, 3.
Exactly. When your parents taught you to count, they just sat there and went 1, 2, 3. Those are the counting numbers. Counting numbers start at 1 and go forever in this direction. Okay. You know, your parents didn't go 1, 1.5, 2, 2.5, or whatever. It was, those are the counting numbers. Okay, and then the next step after the counting numbers, we have what are called the whole numbers. And whole numbers are the same, exactly the same as counting numbers. They're the same as counting, except you add 0 to it. Whole numbers are the same except you put a 0 to it. And you'll kind of get the gist of that. Your parents did not teach you 0 because 0, for somebody who's 1 year old, how do you show them 0? Yeah, you'll hold your hand up and then they'll think you mean O or something, because you can't show a 2-year-old 0 because it's nothing, and how do you show somebody nothing because it's not there, right? And I guess you could give them something, take it away, and then say 0, but that would be way too hard for somebody who's 1, 2 years old. Okay. So all of these so far, so we've got this. Right now we have this. These are all the numbers we've got. And then the next thing is, the next thing on our number discussion is negative numbers. And when you look at a number line, you know, up until probably, I don't know, 4th grade, maybe even 4th grade you did, the only thing you knew about the number line was everything on this side of it. Then, last year, I think we started to add these, which are the negative numbers. Again, negative, the reason we probably don't teach 1 and 2-year-olds is because it's really hard. It's hard to teach it to 5th and 6th graders, much less 1 or 2-year-olds. How do you show somebody what -1 stands for? Okay. Negative numbers, you know, are the opposite of the positive numbers. And the thing you have to remember is this, you know, I always think of negative numbers as like money that you owe somebody. It's a good way to think about it. Okay, because if I were to ask you this, if I were to ask you to compare -1 to -5, what number is actually greater? And the way you think about that is, well, do I have more money if I owe somebody $1 or do I have more money if I owe them $5? What's better off? Or if you look at on a number line, let's just look at the positive numbers over here. Any number to the right of any other number is always bigger than it, right? 5 is bigger than 4, 3, 2, 1, or 4 is bigger than anything here. Same thing is true with negative numbers. Anything to the right is always bigger than this because as you go farther and farther this way, you get more and more in the hole. You know, would your parents rather be negative $1 million or just owe somebody $1? Which one would make them happier? This, they've got a lot more money if they only owe them $1 than if they owe them $1 million. Okay, which means 0, children, 0 is bigger than any negative number. Having nothing is better than owing somebody anything. Having nothing is better than owing anybody something. So everything to the right is always bigger than that, and that's something. It takes a little while to think about that, but I'm pretty sure that you guys can probably handle that. And then just, we're talking about a little bit on the world of comparing numbers. Please make sure if you are given this example, 16 divided by 8 divided by 2. Compared to 16 divided by 8 divided by 2. What do you suppose? Just looking at that, which one is bigger? Which one is bigger? Just looking at that. I don't know. Cassie, just looking at those, which one's probably bigger? They're equal is probably your common thought, but I will tell you that is not true. Kind of set you up for that one. Okay. Well, what is 16 divided by 8? Huh?
2.
And what's 2 divided by 2?
0.
No, 2 divided by 2 is 1. So this side stands for 1. This side over here, because of parentheses and order of operations, you have to do 8 divided by 2 first. What is 8 divided by 2? 4. And 16 divided by 4 is 4. So what's actually bigger? This one. And that is because of order of operations. Now, if it was multiplication, Cassie, you'd have been dead on. Why? Because in multiplication, what property is it? In multiplication has the property of, what property? What property? We did this, didn't we? If you had a parenthesis around this first one, which is what we did here, I hope. Everybody sing along. In multiplication, they would be equal because of what property? What was the property called where you move parentheses? Was that, did we talk about that? Did we talk about that? No. But maybe we don't. That might not be. Let me know. Maybe you didn't talk about it. The associative property says that you can, in multiplication you can flip-flop parentheses and it doesn't matter. But in division you can't, because it does matter, as you can see right here. And I'll give you a case in point. Let's do multiplication. 5 times 4 times 1 is the same thing as, there's that 2. 5 times 4 times 1. What's 5 times 4 times 1? 20, right? 20 times 1. And this one here was 4 times 1, 4. 4 times 5 is 20. These are equal because multiplication has that property. Division does not have that property. So you can't do that. Make sure, children, that if you're given this problem, I see all this work here. Don't just give me a inequality sign. Don't just give me a less than or positive thing. Good point, sir. Or another one that gets people all the time is this one. 1 times 1 times 1 compared to 1 plus 1 plus 1. Just looking at that, people always think that multiplication is bigger. Well, 1 times 1 times 1 times 1 is 1. 1 plus 1 plus 1, 3. So please make sure, not always what seems to be true is true.